All right, Mr. Greats here, giving you a little bonus Unit 4 test review. So I'm going to run you through a handful of problems that you will see on the test so that you can be as prepared as possible if you're taking advantage of this. Number one here, we're going to notice that we are multiplying. And so when we multiply, we are going to multiply our bases. 3 times 4 is going to make 12. And then n to the second and n to the second is going to give us a total of n to the fourth. We are adding 2 plus 2. On this next one, we have a base number of 2, base coefficient of 2, and that's not going to be changing. And then I have n to the fourth and n to the third, which gives us a total of n to the seventh. We are adding 4 plus 3. Down here, I have a base number of 2 and no other coefficients for it to multiply with. I have m to the fourth and m to the fourth. 4 plus 4 is going to give us a total of m to the eighth. N to the second and no other n to the seconds or n's in general, so that's going to stay n to the second. And then I have p to the third and p to the third, and that makes a total of p to the sixth. Oh, for this one, there's literally nothing to do. It cannot be simplified. It is just n to the fourth. For number 5, I'm going to look inside my parentheses. There's nothing that I can clean up. There's nothing that multiplies or can be simplified. So when that happens now, I'm going to look out here at this 4, and we are raising the power of 2 and 4 by the power of 4. So I have m to the second, and it's being raised to the fourth. I have n to the fourth being raised to the fourth. When we raise a power by a power, we multiply. On number 6, I'm going to take care of this power by a power first. So p to the fourth raised to the second power is going to make p to the eighth. And that's multiplying with 2p to the first. And that gives us a total of 2p to the ninth. Okay, down here, you are allowed to take this 4 and distribute it in if you would like. I'm going to do it the other way, though. I'm going to clean up and simplify everything inside my parentheses first. So I have x to the second and x to the third. It's a total of x to the fifth. Y to the fourth and y to the second is a total of y to the sixth. And now that I've done that, I'm going to take this 4 and apply it. And this is going to make x to the 20th, y to the 24th. On number 8, we are dividing. So when we're dividing our base coefficients of 3 and 2, we're going to look to see if they reduce. 3 over 2 does not reduce, so those stay the same. And n to the second, we're going to think about that. That is n times n. N to the fourth is going to be n times n times n times n. And these, for everyone I have on top, cancels out one on the bottom. And I'm left with 3 over 2n to the second, because there were 2 left over. The shortcut would be to subtract 4 minus 2, and that leaves us with 2. On number 9, again, I'm looking 4 and 3 do not reduce. And now I'm going to look here, m to the second, m to the third. I'm going to subtract 3 minus 2 makes 1, and it is in the denominator. And then I have 2 and 3, so 3 minus 2 makes 1, and that's also in the denominator. We write our variable back where we had more. All right, in 10, if I'm looking at my base coefficients of 3 and 2, those do not reduce. I'm going to put p to the second and p to the fourth together to make p to the sixth. There's still p to the first on top. And then I'm going to go ahead and subtract. So I've got 3 over 2, and then 6 minus 1 is 5, so there are 5 p's left on the bottom. On number 11, we are going to simplify as much as we can on the top. So I'm going to look all the way across the top here and simplify what I can. So 4 times 2 is going to make 8. That was these two. I have x to the second, x to the third, and x to the first. That makes a total of 6, x to the sixth. And the y to the third and y to the fourth makes a total of y to the seventh. In our denominator, there's nothing that reduces or simplifies, so I'm going to leave that. And now I'm going to look at this problem, and I'm looking top to bottom. I see I have 6 and 4. So I'm going to have 8. 6 minus 4 is 2. And then I have 7 and 2. 7 minus 2 is 5. I can write 1 in the denominator as a placeholder, or that is the same thing as just 8x squared y to the fifth. In number 12, my base coefficients of 2 and 3 do not reduce, so I'm going to leave them as 2 over 3. And then I have p to the fourth, and I have p to the negative third. And in order to create a positive 3, I can move that up. So p to the positive third, and then that's going to allow me to calculate up p to the seventh. 2p to the seventh over 3. All right, in this one, my base coefficients of 4 and 4, will reduce to 1 over 1. And then n to the negative third needs to move down. So I have n to the fourth and n to the positive third now that I've moved it. I can have 1 on top, and then I'll reduce and simplify n to the seventh. In 14, I'm going to take a look at my base coefficients of 4 and 3. They do not reduce. And I'm going to go ahead and just go through and take care of any of my negative things before I do anything else. So n to the first power stays. M to the negative fourth needs to move. Now it's positive, so I use both of those up. I have m to the second stays. And n to the negative fourth needs to move up in order to become positive. So I've just rearranged everything. And now I'm going to go ahead and go through and put stuff together. So I have 4, n to the fifth, that's 1 plus 4, and 3, m to the sixth, because that's 4 plus 2. I'm going to look at it again. There's nothing else to reduce. There's no items that reduce vertically, like top and bottom, anything like that. So that's our answer. In 15, lots of different ways to approach these. I'm looking at 2 and 2 reducing here. I also see that R3 and R3 are going to cancel each other out, and that would leave me with 2R on the denominator and 1 in the numerator. So this would be our final answer. You could have gone through and multiplied this up and then reduced, but okay, 2v is not going to change. Now I'm going to work through piece by piece. 3 stays in the denominator. U to the negative third moves to the numerator. Now it's positive. V to the fourth stays in the denominator. U to the second stays in the denominator. And V to the negative fourth needs to move up. Now it's positive. Now that I've done that, I'm going to do another line of work here. And let's see. Now that I'm looking at it, I see v4 and v4 would cancel each other out. So I have 2 over 3. I have 1v left on top. And then I see that u3 and u2 I can subtract and get u1 on the numerator. And this would be our answer. All right, let's do some final complicated ones. So we've got the power of 2 raising each of these. So I'm going to end up with 2 to the second power, x to the negative second power. And then I also have 3 raising each of these. So this will give me 2 to the third, x to the third. If you want to treat these as if they were like variables and subtract and get 2 to the first on the bottom, that would be totally fine. 3 minus 2 is our exponents of 3 minus 2 is 1 on the bottom, 2 to the first power. Or you can actually evaluate 2 to the second is 4 and 2 to the third is 8. And 4 over 8 reduces to 1 over 2. X to the negative second needs to move, and there are already 3 down there, so that would be, that's how I would make that positive. And we would end up with 1 as a placeholder, so 1 over 2x to the 5th. On 18, I'm going to go ahead and take care of, well, these are not moving. 3 times 2 makes 6, and positive 4 and negative 3 would make 1. And now I'm doing x and x cancel each other out, so I have y over 6 is my answer. For 19, I am going to clean up as much on the inside as I can first before I distribute my negative 3. The more that I can simplify, the easier and the more manageable this will be. So the first thing I see, I'm going to leave this 2 and this x to the negative 1. That's fine. I am going to take care of 2 to the second and 2 to the x to the second. And that would make 2 to the negative first and x to the negative second. That's negative 1 times 1 and then negative 1 times 2. And then I still have x to the negative fourth and a negative 3 out here. Do a new line of work here. I'm going to leave this negative 3 and I'm going to clean up more inside of here. So just going one piece at a time, I may not have left myself enough room here. This 2 is going to stay. This 2 needs to move up to become positive. This x needs to move down to become positive, and this x needs to move up as well as this x. Kind of inefficient. I could have done some other things there, but we'll just keep moving piece by piece. All right, I'm going to clean up everything inside now. So I've got 4. I have x to the 6th over x, but those would really just leave us with x to the 5th over 1. And since it's over 1 and I'm on a tablet, I can just erase it very easily. So last couple steps, we would get 4 to the negative third and x to the negative 15th. And those are currently sitting over 1. So in order to write them with positive, in terms of positive exponents, this would be 4 to the positive third, x to the positive 15th. 1's on top as a placeholder. This would be an acceptable answer, or you can work out 4 to the third and get 64, x to the 15th. Okay, for number 20, I'm going to take care of this and be left with x to the 16th, y to the 12th. I'm going to take care of this and be left with x to the 6th, y to the 6th. And down below here in purple, that's not changing, so I'm going to leave that as x to the 2nd, y to the 3rd. I'm going to continue cleaning up my numerator, so that's going to be 16 and 6, which is going to give us x to the 22nd, and 12 and 6, which would be y to the 18th, over x squared y to the 3rd. And then the last thing would be subtracting vertically. So we're subtracting 22 minus 2 is 20. And 18 minus 3 is 15. And that's in the numerator, so I don't need to write it over 1. All right, last two examples. Okay, I'm going to work this out and get 2 squared m squared n to the 4th p to the 4th. That's still multiplying with 2m to the negative 1. And heck, while I'm at it, so I took care of this whole bottom. Actually, while I'm at it, let's take this m to the negative 1, and it's supposed to be up here. It'll be positive. And then I'm going to look at my numerator, and this is going to move down to become positive. This is going to move down to become positive. And p to the 4th stays. Okay, I'm going to do a couple things. I see m to the 1st and m to the 1st would cancel. I also see a p to the 4th and a p to the 4th that would cancel. So if that happens, let's see what we're left with. I'd be left with 1 in my numerator because there's nothing. I need that placeholder. I have 2 to the 1st and 2 to the 2nd. I can write that as 2 to the 3rd, or I can work out 2 to the 2nd is 4, and 2 times 4 is 8. 2 to the 3rd is also 8. It would be fine either way. So I work those out. I have m to the 2nd and n to the 6th because I have 2 and 4. There's nothing else to reduce here. And my final problem, I'm going to clean up everything that I can inside first before distributing this. You are allowed to distribute this in, but look at how much chaos that creates. You have to distribute it to everything in there. So I'm going to clean this up so that there's less to distribute to. I'm going to go with 2, not changing. So use that 2. H1, H4 would make H5. I use those. K4, K negative 1 would make K3. And J4 is just going to stay J4. I also have H, J to the 3rd, K to the 3rd in the denominator. Okay. I see some things that are going to cancel out here. I see that K to the 3rd and K to the 3rd are going to cancel each other out. And then I'm going to just rewrite the other pieces that I need to. I have 2. H to the 5th and H to the 1st. 5 minus 1 is 4 on top. And J4, J3. 4 minus 3 is 1, and that's also going to end up on top. J1. And, that leaves me with just a 1 on the bottom because I ran out of everything down here. When our 1's on the bottom, we don't necessarily have to include that, okay? All right, let's distribute in this negative 3. So this will make 2 to the negative 3rd, H to the negative 12th, J to the negative 3rd. And this is all sitting over 1. I guess I could have left it. This also would have then become 1 to the negative 3rd, Don't get too lost on that, though. Okay. And then if all these are in the wrong place, then to put them in the right place, I've got to move to the positive third, or 8, either way. I have h to the positive 12th and j to the positive 3rd, and that's underneath 1 now. This would be your answer. All right, hopefully this helps you feel ready for the test.